Let's start with something that seems so simple that most of us never even think about it. Fire. You've seen it your entire life. A candle burning quietly in the dark, a match lighting up for a second, a campfire glowing while people sit around it. It feels completely normal, completely obvious. Fire burns, of course it does. That's just what fire does. But here's the strange part. The moment you stop and actually ask the question, why does fire burn? Things begin to get weird. Most people will answer instantly. They'll say something like, because it's hot, or because it's fire. And in everyday life, that explanation feels good enough. We move on without thinking twice. But if you slow down and push the question just a little further, you suddenly realize something surprising. The answer isn't as simple as it first seemed. Think about it. What does it actually mean for something to burn? Why does touching a flame instantly hurt your skin? Why does that bright orange light appear when something is on fire? Why does a flame even exist at all? When you really sit with that question, you start to see how mysterious everyday things actually are. We live in a universe where invisible processes are constantly happening around us. Atoms moving, energy transferring, tiny particles interacting in ways our eyes can't see. And somehow all of that hidden activity shows up in our world as something we casually call fire. And that's the moment reality starts to crack open a little. Because the deeper you go into that question, the more layers appear. At first you think you understand it, then you realize you only understand the surface, then you discover there's another level underneath that and another one after that. This is the beauty of curiosity. A simple question about something ordinary can lead you straight into the deepest laws of the universe. Something as familiar as a flame can quietly connect you to chemistry, to atoms, to electrons, and eventually to the strange rules that govern reality itself. And here's the wild part. The universe is built in such a way that even the most basic experiences, light, heat, a flickering flame, are actually the result of incredibly complex processes happening on a microscopic level. Processes that no human can directly see, but that shape everything we experience. So when we ask why fire burns, we're not just asking about a flame, we're asking about the structure of reality. We're asking about the hidden rules that make the universe behave the way it does. And once you start asking questions like that, you realize something powerful. The world around you is far deeper and stranger than it first appears. And that simple question about a flame is where the journey begins. Now, once you take that first step and start asking the deeper question about fire, the next layer begins to appear. At this point, science gives us an answer that feels solid. It tells us that fire burns because of a chemical reaction called combustion. And at first, that sounds pretty straightforward. When something burns, like wood, paper, or gasoline, it's reacting with oxygen in the air. The fuel and the oxygen meet, their atoms start rearranging, and that reaction releases energy. That energy shows up as heat and light, which is the flame we see dancing in front of us. So in simple terms, fire is not really an object, it's an event, it's a process happening right in front of our eyes. The wood itself isn't the flame is what happens when the atoms inside that wood start interacting with oxygen. Bonds between atoms break apart, new bonds form, and during that change, energy escapes. That escaping energy becomes the warmth you feel when you hold your hands near a campfire. It becomes the glowing orange light that flickers in the dark. Think about a piece of wood sitting on the ground. By itself, it just sits there quietly. Nothing dramatic is happening. But the moment enough heat is added, maybe from a spark or a lighter, the atoms inside that wood start moving faster. Eventually, they reach a point where they can react with oxygen in the air, and once that reaction begins, it feeds itself. More reactions create more heat. More heat triggers even more reactions. And suddenly you have a flame. It's almost like a chain reaction where the universe is releasing stored energy that had been quietly locked away inside chemical bonds. But here's where things start getting interesting again. If combustion is just atoms rearranging themselves, then another question immediately shows up. Why does that rearrangement release energy in the first place? Why does the universe reward certain atomic arrangements with extra energy being released as heat and light? Because if atoms could rearrange in a million different ways, why do some of those ways produce a violent flame while others don't? At this point, you begin to realize something important. Chemistry explains what is happening, but it doesn't fully explain why those reactions behave the way they do. It describes the process, but it hints that something deeper underneath is controlling the rules. The flame in front of you is really just the visible surface of a much deeper system, a system built from atoms, electrons, and forces that are following extremely precise laws. So even though the explanation of combustion sounds satisfying at first, it actually opens the door to an even deeper mystery. Because once you understand that fire is chemistry in motion, the next question becomes unavoidable. Why does chemistry work the way it does at all? So now we go one layer deeper. If fire burns because of combustion, and combustion is just atoms rearranging themselves, then the real story is happening inside those atoms. The moment you zoom into that level, the picture changes completely. What looked like a simple flame suddenly becomes a dance of tiny particles following rules that are almost impossible to imagine. Inside every atom are electrons moving around a nucleus. These electrons aren't just randomly floating. They follow very specific patterns, almost like invisible lanes or energy levels. And those levels matter a lot because electrons always prefer to be in the lowest energy position they can possibly find. Think of it like a ball rolling downhill. The ball naturally wants to settle at the lowest point in the valley because that's the most stable place. Electrons behave in a similar way. They naturally move toward arrangements that require less energy to maintain. When fuel and oxygen come together during combustion, the electrons inside their atoms start reorganizing. Old connections between atoms break apart and new ones form. During that rearrangement, the electrons drop into more stable energy positions. And here's the key moment. When electrons fall into a lower energy state, the extra energy they were holding has to go somewhere. Energy can't just disappear, so it escapes. Sometimes it escapes as heat. Sometimes it escapes as light. And that escaping energy is exactly what we see as a flame. That glowing fire in front of you is basically energy leaving atoms as their electrons shift into more stable arrangements. What looks like a simple flickering flame is actually millions of microscopic events happening every second. Electrons jumping, bonds breaking, bonds forming, and energy pouring out into the world around you. It's incredible when you think about it. A campfire isn't just burning wood. It's a massive chain reaction of tiny quantum-level changes happening faster than our minds can picture. Every spark, every glow, every wave of heat is the visible result of those invisible shifts. But this is also the point where things start to feel a little strange again, because now we understand that combustion works because electrons prefer certain energy levels. We know that atoms rearrange themselves to become more stable. But that raises another question that's even deeper. Why do electrons follow those specific rules at all? Why do atoms have energy levels instead of just behaving randomly? Why do the laws of quantum physics allow certain arrangements and forbid others? The deeper you go, the more you realize that what we call explanations are really just descriptions of patterns the universe follows. We can observe those patterns, measure them, and use them to predict what will happen. But the ultimate reason those patterns exist in the first place becomes harder and harder to answer. And suddenly that simple flame you started with has led you all the way into the strange world of quantum reality, a place where the true reason fire burns may be far deeper than we ever expected. At this point in the journey, something interesting starts to happen. We began with a simple question: why does fire burn? Then we discovered combustion. After that, we went deeper into atoms and electrons and energy levels. Each answer seemed satisfying for a moment, but every time we found an explanation, another question quietly appeared behind it. And this is where the nature of curiosity really reveals itself. Because when you keep asking why, you eventually reach a strange boundary. Science is incredibly powerful at explaining how things behave. It can show us how atoms combine, how electrons move, how energy transfers from one place to another. It can measure these processes with unbelievable precision. It can even predict them. But when the question becomes, why do the laws themselves exist this way, the answers begin to change. For example, we now know that electrons prefer lower energy states. That's why chemical reactions release energy. But why do electrons behave like that in the first place? The answer science gives is that this is how the laws of quantum physics work. That's the rule built into the universe. Then the question naturally becomes, why are the laws of quantum physics the way they are? And here's the surprising part. When you follow this chain long enough, you eventually reach a point where science stops giving deeper why answers and instead describes the patterns that reality follows. It tells us the rules. It shows us the equations. But it also quietly admits something important. These rules are simply how the universe operates. In other words, the deeper you go, the more you realize that reality is built on fundamental laws that just exist. That realization can feel a little unsettling at first. Our minds are trained to look for final reasons, ultimate explanations that sit at the bottom of everything. But the universe doesn't always give answers in that way. Sometimes it gives us layers of understanding instead. And yet even that limitation reveals something beautiful. It shows that the universe is structured, consistent, and governed by precise rules that allow everything to function, from the smallest atoms to the largest galaxies. The same laws that guide electrons inside a burning flame also guide stars shining across the cosmos. For a believer, that order doesn't feel random. It feels like a sign of deep design and wisdom built into creation. The fact that the universe follows stable, understandable laws is itself something remarkable. It allows human beings to explore, discover, and reflect on the world around them. So when we ask why fire burns, we're not just asking about chemistry or physics. We're stepping into a much bigger realization that our understanding of reality always grows layer by layer. Each answer brings clarity, but also humility, because the deeper we look, the more we recognize how vast the structure of creation truly is. And sometimes the most honest answer is simply this: we understand how the universe behaves, but the ultimate reason behind those laws belongs to a knowledge far greater than our own. And when you step back and look at the whole journey, something amazing starts to become clear. We began with a tiny, ordinary thing, a flame, something so common that most people barely think about it. But the moment we asked a deeper question, that simple flame slowly pulled us into a much bigger story about the universe itself. Think about what just happened. A small fire led us to chemistry. Chemistry led us to atoms. Atoms led us to electrons and energy levels. And from there we ended up talking about the fundamental laws that shape reality. All of that hidden complexity, all of those invisible processes sitting behind something as familiar as a burning match. It's almost humbling when you really let that sink in, because it means the world we live in is far more layered than it appears on the surface. Every ordinary experience is actually connected to a deep structure of rules operating beneath our senses. We see the flame, but we don't see the atoms rearranging. We feel the heat, but we don't see the electrons dropping into lower energy states. We watch the light flicker, but we don't see the microscopic events releasing that energy into the universe. And yet those invisible processes are real. They're happening every second, shaping everything around us. What's even more fascinating is that the universe didn't have to be this way. The laws of physics could have been chaotic or inconsistent. Atoms might not have formed stable structures. Chemical reactions might not have released energy in predictable ways. If the rules were slightly different, stars might never have formed, planets might never exist, and life itself might never appear. But instead, the universe operates with extraordinary order. The same principles that allow fire to burn also allow stars to shine. The same rules governing electrons inside atoms also allow molecules to form, cells to exist, and life to grow. There's a deep harmony in how everything connects, from the smallest particle to the largest cosmic structures. And when you think about that, the simple flame in front of you begins to look different. It's no longer just a fire. It becomes a window into the hidden architecture of creation, a reminder that behind every ordinary moment lies an extraordinary system of laws holding the universe together, laws that human beings can study, explore, and slowly begin to understand. For someone who believes, that realization carries a special kind of meaning. The order of the universe doesn't feel empty or accidental. It feels like a sign pointing toward wisdom built into the fabric of existence. The consistency of these laws allows us to seek knowledge, reflect on creation, and recognize how vast and intricate the world truly is. And that brings us back to the question we started with. Why does fire burn? At first it looked like the simplest question in the world, but by the time we followed it all the way down, it quietly revealed something much bigger, that even the smallest flame is connected to the deepest structure of reality. And once you truly see that, you realize the universe has been far more extraordinary all along.